Hello everyone. Since the book does not provide the videos for section 4.3 and 4.4, so I recorded a video for these two sections. These two sections mainly introduce the difference between the random variables and continuous variables and the how to calculate the expectation for distribution and the standard deviation of a probability distribution. Let's look at the first one, random variable, discrete random variable. Discrete random variable. What is a discrete random variable? A discrete random variable has either finite or countable number of values. Okay, so the first one has to be finite. And it has to be or countable. Okay. For example, the points. Okay, the points when you play basketball, you have points, right? The points, the 1, 2, 3, 4, 5, like the points, discrete. So for the discrete variable, we will have the numbers. So the discrete x will be equals 0, 1, 2, 3, continue. For example, the number of light bulbs that are burned out in a room, or the number of leaves on a random selected oak tree. So basically it's countable. You can count it like 1, 2, 3, 4, 5, 6. The number of apples, the number of pumpkins, you can count it. Okay, so that's discrete. All right, discrete random example. What number of students? Number of apples. Okay, number of leaves. You can count it. Basically, it's a discrete random variable. Okay. So next one is the what is the continuous variable? Okay, continuous variable. The second one is continuous variable. So continuous random variable is continuous. For example, the time is continuous. Time. Okay. You can't stop the time. It's not count like 1, 2, 3, 4, 5, like the time. Even between 1 second and the second, you never stop. You can't count the time. It's measurable. Okay, you measure 1 hour, 2 hours. Okay, so the feature is measurable. Another example would be the length. For example, the length. Or the area. You can measure it, like how long is it. For example, the length of that is, this is continuous. The length of a segment is continuous. Or the area, okay, the area. Even there's a hole there, well, it's still continuous everywhere except the hole here, right? So the area is measurable. If it's measurable, it's continuous variable. So that's the difference between discrete random variable and a continuous random variable. Okay, so next, I would like to introduce how to find out the expectation of the discrete random variable. Okay, suppose we have a distribution. Suppose we have a distribution of which is Before that, I would like to repeat, we may have introduced that in section 4.2, but I would like to repeat that again. So as, for example, X is a random variable, well, discrete random variable. X is a discrete random variable. Okay. So how do we know if it's a discrete probability distribution? Okay. If it is a probability distribution, we add all the probability together. We add all the probability together should be equals 1. And then the second, the probability of each variable, the probability of the random variable is bigger than equal to 0, less than equal to 1. Okay. So next, let's look at how to find out the mean value of the random variable. Or expected values, the same thing. The mean of a discrete random variable. So mu x equals px, the x times the px. Okay, this is the formula for the mean value of a discrete random variable. Let's look at an example. Suppose you have x is the random variable, discrete, and also its probability. For example, if you toss a coin or toss a pair of dice, you would have if you toss a pair of dice or just a single dice, you would have the point 0, no, you can't have 0. 1, 2, 3, 4, 5, 6. You have 6 outcomes and have 6 probabilities. Normally, if it's fair, and it's going to be 1/6 for each one. If it's a fair of coin, it's half for each side. So, for example, the x, you have 6 possible outcomes: 0, 1, 2, 3, 4, 5. Those are the random variable values. And then next, suppose we have the probability for each random variable. The probability to get x equals 0 is 0.06. The probability for x equals 1 is 0.58. Well, these values is just given, random. Okay. When you have an example in your homework, these numbers will be given to you. 0.1, 0.03. For example, this last one, I don't know what it is. If I ask you, what is the probability that you get x equals 5? For example, if I ask you, what is the probability of x equals 5? Okay, so the probability for you to get x equals 5 is going to be 1 minus all of the other probabilities together. Because you add all the probability together, it will equals 1. Does it make sense to everyone? Yes, okay. So you add all of the probability together should be equals 1. 0.06, adding all of them together, all the possibilities, should be 100%. Okay, that's what it means. For example, when you take a class, your probability for your outcome would be just either pass or fail. The probability of your pass is 70%, you pass the class. Well, for sure you have 30% to fail the class. So 1 minus the other probabilities. So you got this is 0.01. So now we fill this one with 0.01. Okay. So next, we would like to find out the mean value of the probability distribution. I want to find the mean value of this probability distribution. The mean value of this probability distribution, you just add all the x multiplied by px. What is the meaning of that? It means you use 0 times its probability, 0.06, plus 1 times its probability, 0.58, plus 2 times its probability, 0.22, plus 3 times its probability, 0.1, plus 4 times its probability 0.03 plus 5 times its probability 0.01. So adding all of them together, the mean value of this probability distribution is 1.49. You can use a calculator to do that. Okay, this is an example of how to find out the mean value of a discrete random variable. And the next, I would like to introduce how to find out the standard deviation. This is the mean value of a random variable distribution. So how about the standard deviation? The standard deviation of a discrete random variable is sigma x equals square root of x squared times px minus mu x squared. So in order to find out the standard deviation, first we need to find out the mean value. Okay. Let's still look at the same example. Let's still use exactly the same example for this from the previous example. Okay. We still have the same example. We have 0, 0.6, same distribution. We still use the exact same distribution. Okay. Let me see if I can make it. So we still use the same distribution, this one. We want to find out the standard deviation of this random probability distribution. Okay, this probability distribution. First, we have this x squared px. We know that mu x is given now. So we know mu x equals 1.49 is given to you, is given to us. We just find from the previous. And now next, I need to find out what is this. Okay, so this one, sigma x squared times px. This equals sigma x squared 0 squared times its probability 0.06 plus 1 squared times its probability 0.58 plus 2 squared times its probability 0.22 plus 3 squared times its probability 0.1 and plus 4 squared times its probability 0.03 plus 5 squared times probability 0.01, and we add all of those together. This equals, okay, we add all of them together. This equals what? You can use a calculator to find that, and you see. So it's x, you add all of them together, it's going to be, I don't know this answer yet, so 0 plus 0.58 plus 0.88 plus 0.9 plus 0.48 plus 0.25. Okay. And let me do that real quick. What is this final answer? Okay, so 0.58 plus 0.88 plus 0.9 plus 0.48 plus 0.25, answer is 3.09. Okay, so then we plug this both of the value into the standard deviation. So the standard deviation equals square root of 3.09 minus 1.49 squared. So the answer is minus 1.49. So answer is square root of 0.8699. The answer is 0.9327. This is the standard deviation for the previous probability distribution. Okay, so first you find the mean value, and then you find the standard deviation of the random variable of the probability distribution. Okay, so that is the difference between the discrete random variable and the continuous random variable, and how you find out the mean value and standard deviation of a probability distribution. Okay, this is the example.